Hi guys, in this video we're reviewing how to solve absolute value equations. We know the very basics that if there's a number inside the bars mean absolute value. So the absolute value of 2 equals 2, and the absolute value of negative 2 also equals 2. In this problem we have to find every value of k such that the absolute value of k is equal to 8. Okay, so to do that we could undo the bars such that k is equal to 8, or k could also be equal to negative 8. We know that because if we plug in those values, absolute value of 8 is equal to 8, and the absolute value of negative 8 is also equal to 8. In this problem, undoing the bars, we could write that n over 2 is equal to 5, and n over 2 is equal to negative 5. So we have to solve each of those separate problems. Solving the first one, we multiply by 2 to both sides. N is equal to 10. And here when we multiply both sides by 2, we get n is equal to negative 10. So both of those numbers make the number sentence true. Following our pattern for this one, we could write negative 10 plus k is equal to 13, and negative 10 plus k is equal to negative 13. I call this move undo the bars. Undo the absolute value bars, which gives you two cases. Okay, so solving these, when we add 10 to both sides, k is equal to 23. And when we add 10 to both sides here, we get k is equal to negative 3. Notice that for this example, k is not equal to the plus and minus of the same value. Doing this problem, we can write that 8 plus n is equal to 1, and 8 plus n is equal to negative 1. So subtracting 8 to both sides, n is equal to negative 7, and subtracting 8 to both sides here, n is equal to negative 9. So those are our two answers. What's different about this one compared to the other ones is that the absolute value is not by itself. So a first step is to get those absolute value bars alone to solve for them. So we have to, so notice that this part right here, this minus 3, is not within the bars. By the bars I mean these absolute value bars right here. Okay, so we're going to move the negative 3 over to the other side. Plus 3 plus 3. Then we'll have the bars are completely by itself. Absolute value of n divided by 10 is equal to 1. Now that the bars are on one side of an equation, we can rewrite it with the two cases. N divided by 10 is equal to 1, and n divided by 10 is equal to negative 1. So here n is equal to 10, and n is equal to negative 10. Notice that if I plug in 10 back into my equation, I would have 10 divided by 10 is 1, absolute valued, which is 1. 1 minus 3 is negative 2, so it checks out. It also checks out for negative 10. Negative 10 divided by 10 is negative 1. Absolute valued is 1, and 1 minus 3 is negative 2. So similarly for this problem, we have to first get the bars by itself. We have this extra plus 6 right there, so we're going to take that away from both sides. Then we'll have absolute value of negative 4a is equal to 20. So negative 4a is equal to 20, and negative 4a is equal to negative 20. When we divide by both sides by negative 4, we'll have a is negative 5. Dividing both sides by negative 4, we'll have a is equal to 5. So those are our two solutions. The common mistake for this problem is to try to do minus 8 here and minus 8 here. The reason you cannot do that is because that 8, that plus 8, is locked within those bars. So we're not able to subtract 8 to both sides yet. So rewriting the problem, what we have to do first is deal with this minus 2 that's outside of the bars. So we'll add 2 to both sides, and we'll get negative 8p plus 8 is equal to 24. Now that the bars are by themselves, now we're allowed to undo the bars and get our two cases. So we'll get negative 8p plus 8 is equal to 24, and negative 8p plus 8 is equal to negative 24. Solving for p in both of those cases, negative 8p is equal to 16, so p is equal to negative 2. And here we'll have negative 8p is equal to negative 32, so p is equal to 4. In this problem, we have to get the bars by themselves first, so we'll take away 6 and get 9k minus 9 in absolute value bars is equal to 54. Writing it as two cases, negative 9k minus 9 is equal to 54, and minus 9k minus 9 is equal to negative 54. Okay, so add 9 to both sides. Negative 9k is equal to 63, so k is equal to negative 7. And here when you add 9 to both sides, you'll have negative 9k is equal to negative 45, so k is equal to 5, positive 5. So those are our two answers. In this problem, we have to get the bars by themselves, so I'm going to circle the absolute value bars. So we have to first add 5 to both sides. And then we have to divide by 4 to get the bars by themselves. So 4 of the bars, 10v plus 2, is equal to 48. Dividing by 4, because the 4 is on the outside of the bars, 10v plus 2 is equal to 12. Now I can undo the bars. That's a 10 there. So undoing the bars, I'll have 10v plus 2 is equal to 12, and 10v plus 2 is equal to negative 12. Now I can go ahead and solve these. So let's subtract 2 and divide by 10. V is 1. And here subtract 2 and divide by 10. So I'll have V is negative 14 tenths. Which is equal to negative 7 fifths. Similarly here, we want to first subtract 3 to both sides and get 3, absolute value of 9r minus 5 is equal to 96. So dividing this by 3, we'll have absolute value of 9r minus 5 is equal to 32. So we can write 9r minus 5 is equal to 32, undoing the bars, and 9r minus 5 is equal to negative 32. So solving those two equations, when we add 5 to both sides, we'll have 9r is 37, so r is equal to 37 ninths. And the other side, when we add 9 to both sides, we'll have 9r is negative 27, so r is negative 3.